All right. I think we're live. Chris, long time no see.
We're live on LinkedIn now too. This is an upgrade. Hello, LinkedIn.
While you were away, we made huge advances. Like,
I mean, your camera alone, Dan, you look fantastic. So,
thank you. Thank you. I
Mhm.
actually I can't show it I guess here, but um the I still need to get like curtains for the window that's behind my machine cuz even when
Mhm.
I have the blinds closed, I'm still like pretty uh
Yeah.
it's like very white. Um, but the my light source, which is helping a little bit, is a lamp with a white T-shirt tied around
Whatever
it.
works.
So yeah,
Yeah.
it looks terrible though.
Pandemic hacks. We all did it. We're all through it. We all live that legacy. So,
Right. Well, I don't know if I'd say I'm totally through it. I think I'm still I'm still having residual effects.
sure. Yeah.
But
But that's the legacy part. Yeah.
yeah, right. But you've been out for a little while. How's it feel to be
I
back?
have. It's been great. Came back to a platform that's even better than I left it, and a lot of new, exciting hardware to work on. Actually, I don't know, did Mike, did Mike go over the boards? He probably didn't. We could maybe show him on here.
Yeah.
Had a Rev B of a bunch of hardware that we do in DevRel delivered, and exciting new projects. So yeah, just a lot of things going on, a lot of things in flight, and it's like fire hose, you know.
Right. Well, cool. Well, we're definitely glad to have you back, and it worked out well on timing since Mike is out this week. So it was just seamless.
Taking a
You
well
just
deserved
slide right
break.
back in.
Yeah.
Yeah. So, but topics for today. I know you did an event earlier today, and I think there might be some things related to
Mhm.
that you were going to show off. Was thinking we could run through some of the kind of releases we've had over the last
Sure.
couple of weeks while you've been out,
Yeah.
and
This is great.
then
I mean, I
yeah,
can learn from you what's been changed. Actually, every time I log into the console now, we've been doing a lot of UI changes too. I'm like, this is different. I'm like, oh yeah, things are happening. Yeah, let's move
yeah,
it.
right,
Moving and
right.
grooving.
Absolutely, yeah. I think the console is like every couple of days there's like a pretty good change, which
Yeah.
hopefully it's not too jarring. We had one big update that I know we covered on the stream, but since then it's just been small improvements.
I have in my head, like, so I used to work with, I am the old engineer now. I used to work with some older engineers, and like the phrase that always like sticks in my head that I always try and be mindful of, like especially like website stuff, like where just tell me where to click. Tell me
Yeah.
where to click. So if you move where to click, you got to tell people, you know.
Right, for sure.
A bunch
Well,
of
that's
like
what
old
uh,
hardware engineers that are like digging into firmware and just tell me how to make it build. All I care
yeah.
about is building the sample, like
Make it work. Yeah, absolutely.
yeah.
Um, cool. Well, let's start off and go through a couple things that have launched. When were you? It's just been basically since the new year, right? That you've
That's
been
right.
out.
Yep. Yep.
Okay. So I think there's three main ones. I was kind of looking at the blog as the guide here.
Yeah. Yeah.
Um, let me pull that up. All right. So we have
Can we tell if we have
your
audience right now? Do we know if anyone's watching? I guess we do have a comment section and we can see your comments and pull them into the stream. So,
that's right.
yeah.
Um, So we have your beautiful new post that went out this week.
Mhm.
Um, but maybe going back, let's just go back to beginning of January, which would be when you were first out. I don't know
And I
why my
disappeared.
machine is moving so
Yeah.
slow. Let's see. So I think the first thing was the Goliath simulator, which I know you've seen before, but for folks who were not there when we showed it off in the stream, basically in the Goliath console, we now have a simulator, um, and it allows you to send data, LightDB stream data specifically for right now on behalf of a device. So you can just pop that open anytime and test out, especially if you have like an output stream or something set up. It can be really useful. Or if you're trying to
Totally.
see how some data is formatted or something like that. Have you used this at all yet, Chris?
Yes, once so far. But the thing that I was thinking about with this
Hmm.
is like, say I am a hardware engineer. Say I'm a hardware engineer. Let's pretend I'm a hardware engineer, Dan, and I'm working with my cloud team, And I
Mhm.
want to. One of the things that I always have anxiety about is like what if my hardware is just wrong? Like
Mm.
it's happened. It has happened, and it will happen in the future. And so like I still need to be able to send something to them. And having a simulator like this is actually great to be able to just you know take a best approximation of what will be coming through Light TV Stream or future other services, and like that's better than nothing. Like basically, I want to like have like this virtualized representation, which is what effectively the cloud instance is as well, and have that just to force the issue basically, and to be like, here's what the packet will look like when I finally get my hardware to send some packets.
Yeah, yeah, absolutely. And I think like as far as further iterations of this, I think we want to lean further into that because one of the things that we could do is make that a little more formal because like here, you're putting in JSON and you can send it. But we might want to be able to say that you can actually, write a schema or something like that. And at
Mm-hmm,
that
mm-hmm.
point, you can do it in kind of both directions. One where you could like generate data for the whatever cloud services to consume, but then you could also send data to Goliath from your devices and validate, that
Yeah,
you're sending in the right format.
right. And I think that's important too because like Goliath is that glue layer kind of between hardware, like before basically people had to make this glue layer themselves, and Goliath has become that infrastructure, become that in between, and being able to do the bi-directional. It's just like having like it's like any API, right? You need to have this somewhat standardized interface, except when you're building it all yourself, like when you're building a full end-to-end IoT solution, it's like you can really make a lot of odd decisions throughout the process, but it just needs to
Mm.
be standardized. And if you start to do that through like a simulator like this, then you start to get that standardization pulled forward in the design process. And like that is really important because it's not like, wait, where's my bit? You didn't add that one bit that I needed.
Right, 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 for sure. Um, so yeah, that was right at the beginning, I think, of when you were out. Um, but that was the first kind of launch we had, and I think we kind of alluded to it then, and still won't go into too much depth. But one of the things you might notice if you're a developer is that we're sending device data from the browser, and we support CoAP for our device API today.
How do
There
you do
has
it,
to
Dan?
be there has to be some way, right, that we're sending this data, and obviously it's over HTTP. But that is uh, alluding to what's to come. But actually, for a little peek behind the scenes, I guess this was a really good way for us to roll out new support and test out some things in kind of a low impact manner, right? Because obviously, we want the simulator working at all times, but it's not as critical as the actual data that's coming off the devices.
Yeah. Great. Well, more simulator, please.
More of that. I think maybe here's an interesting one that I think you've already potentially been exposed to is moving the training over to code spaces. Have you already
Ah,
experienced that yet?
yes. Well, I've been peripherally involved. I actually was showing this at that thing I was doing earlier, so I actually have the code spaces up and going right now.
Oh, pull it
Um,
up.
yeah.
Let's see it.
So one of the things, did you and Mike talk about this on the stream at all, or no?
Yeah, we did a little bit. Or I think we talked
Okay,
about it in depth once, and then we've alluded to it a few times. But
Mhm.
different folks tune in every week, so.
That's true. Yeah. Um, I have forgotten how to use StreamYard. Make sure I don't share my Slack instead.
Yeah, I'm
But
always
hopefully this is
worried
the
when I
right thing.
say present. Like, I don't know if you select before or after. That's why I always forget.
Yeah.
And I'm like, am I going to show everything if I click
Yeah.
present?
Yeah.
So,
That's right.
well, concerning.
So this is training.goliath.io is our training site, which I'm sure you talked about with Mike last time. This is all self-driven, so people could go here anyways. In the past, it was using something called Chasm, which we've talked about a bunch, where it's basically that was like a virtualized desktop in the browser. Now we switched to Code Spaces, where now it's just VS Code in your browser. But the really magical thing about this is you click this link. Oh, sorry, I'm going back and forth. Use this direct link, and yes, it basically pops up this page, and you click this create a code space, and 30 seconds later, you have a full Zephyr build system, including all the tooling that you need, including the repo that we're showcasing here, and it's just ready to go. And like the fact that I can just type in West, which I should make this a little bigger probably, and like get a West interface, like
Hmm.
uh, I love Zephyr to death, but the tooling is still a little bit tough to get up and going. And like a lot of vendors have great capabilities to like make it easier. But like this method, getting to a West interface was really tough in the past, and now it's 30 seconds. And like to me, that's actually amazing from a lot of perspectives. I feel like from a lot of other ecosystems too.
Yeah, yeah, absolutely. Also, I know you loved maintaining EC2 instances, but
I did,
so sorry to
yes,
take that away from you.
yes. Being a DevOps person is not my calling, I'll say.
Right. Fair enough. Yeah, and I think a lot of folks are also already familiar with GitHub and just kind of like, navigating this tooling. So the fact that you can just get to it so easily, I
Hmm.
think is super beneficial.
Yeah. Yeah. And so, like I said, you can go and follow through this at any point. This is our developer training site. There's the intro to Goliath part where it's basically you're just loading up a pre-compiled example. But then the Zephyr training is basically you're going and you're doing the compilation, you're trying stuff out, you're following along. It's all self-driven, but we also have a live training that's happening on March 20th. So if people want to be talking to folks like Dan and myself on video chat while we're also going through it with other people, there's a sign up somewhere. Training sign up. Develop a lot of training stuff. Training. Yeah. There it is. Nope, that's not it. I will find that link and I will drop it in the chat.
Cool. Um, for after we build in this code space environment, what's
Mhm.
the process then for getting the build onto the device?
That's the part that I am not as privy to. It is in the docs. Oh boy. Um,
Didn't
I
mean to
think
put you on the spot
there
there.
was a West there was a West command in the old ways of doing it. I think it's now a it's basically you're just going to download the binary and click add file, browse. Nope, that's not it. Download the binary. Yes, reading. West download. That is the answer. And actually, I already built in this directory, so it actually would be West download. This is a custom command. Nope. CD app. West download. I'm not sure there's anything there. There we go. And so it just downloaded this. It's got a timestamp. It's got the name of the binary we were building because there's different folders here as well. So you see we were building Hello World,
Hmm.
and yeah. So now this is in my downloads folder. There we go. And I can click this, click download, and it's on my machine. So then I
Ah,
could load it on the VS Code box thing. So
I see. Yeah, that makes sense. I didn't know whether we were doing this by first doing the precompiled binary and then like OTAing the new build onto
ah
it. But
no,
it's nice that you can do this as well.
that's not a bad idea. We'll talk, Dan. We'll
All
talk.
right, sounds good. Um, cool. Well, that's awesome.
Yeah.
Hopping back over to the blog. Let's see
The
here.
blog.
Oh, did I go away from it?
Oh,
Oh, no, I got it. Here we
you have
go.
to share your own screen. Yeah.
There we go. All right. So that was all for this page.
And if people want to
Our
get all this stuff in a newsletter format, you can sign up for a newsletter as well.
That's right.
Yeah.
Highly recommend. The styling is great too. I just love the aesthetic. That's why I subscribe. So
Got it. Yeah.
So I think the next biggest one here was the Zephyr support in the firmware SDK and kind of announcing moving over to that. I believe the training is now also updated to the new firmware SDK, and I think
Mhm.
is it just the reference design templates, or have some of the reference designs themselves been ported over?
It's just the template right now. So all the reference designs that we do are based on the template, but then you have to pull those changes through
Mm,
as things get pulled into the template itself. And I don't think that's happened yet. So
gotcha. And the new Modbus reference set, which that's
Mm,
actually something we should talk about because I don't think we've talked
sure,
about it on
sure.
this yet. But was that on the new template or prior to the changes?
That was on the old template as well because it was
Gotcha.
started a while ago. Yeah.
Do you want to talk about that actually? Because I don't know if we have a blog post for that. I think we
We
probably
do.
do.
Yeah, we do.
Here we go. Um, Folks can go in and watch a video about it. But do you want to talk a little bit about Modbus because you also wrote about it this week, and this was a really interesting reference design that came through.
This is actually I published about it. I didn't write this. This is all Chris Wilson, our friend and contractor, who did that. So yes, so I do know about Modbus though.
Right.
You're saying I
You
wrote
wrote
about
about
the
you wrote
newsletter.
about Modbus, yeah. Hmm.
Got it. Yes. So Modbus is a rather old industrial standard from 1979, and it's basically kind of you go into just about any factory these days, and something's going to be running Modbus. And there's different types of it as well, but it's just an industrial standard. And the reason we wanted to do a reference design around it is because even though we're doing, we talked to one of our friends who was in the industrial space, and he suggested these temperature and vibration monitors. They're often on AC motors that are in the factory. But it doesn't have to be those, right? It could also be like ultrasonic sensors or temperature sensors or just a wide range of end sensors in an industrial context are using Modbus. And I'm going to get the words wrong. I'm sure Chris wrote about it on the actual blog post for it. But there are basically kind of single bit registers. Those are usually called coils, I believe. And then there's also larger, I think 8 or 16 bit kind of like words. And Modbus basically just says, hey, you got this list of registers here, and sensor one might have this set of registers, and sensor two has this set of registers, but the interface is the same. And it really starts to standardize some of these really niche industrial sensors. And basically, the reference design itself, even though, like I said, even though we're using this Banner Engineering Modbus sensor, it doesn't have to be that one. We could swap it out for another one. You just have to change which registers you're talking to. And so much like we have different I2C sensors on the board, we might have a temperature sensor and a time of flight sensor. They're both talking I2C, but the registers are different. You need to talk to those registers different. So all you have to do then is plug in and change the code around, and now you have this entirely new design.
Hmm.
And so, yeah, so basically, this new design basically opens up all the Modbus stuff that's out there. You can start talking to it. Modbus RTU, which uses RS-485. Yes.
Gotcha. And do you know like why Modbus has been uh such a big part of the industrial space as opposed to like I2C or other protocols?
Yeah. So I2C is really meant for like small sensors that are close to the processor that's talking to them. So because it's like an open drain, that sort of thing. Similarly, SPI is like just not good for harsh environments, right? So that's SPI. And that's serial peripheral interface. Like, so a lot of the stuff that you might have on a motherboard, like talking from processor to sensors nearby, is not going to be the same as like PLC, which is often the thing talking to these large industrial sensors. It might be talking over a run of cable that's like 500 feet or like, a couple, 150 meters, right? And like, but basically, when you start using RS-485, it's more noise immune. It handles spikes better, that sort of thing. And so basically, being in harsher environments usually predicates different needs.
Hmm.
Now there are other industrial standards out there like Profibus and EtherCAT and all these others. I think Modbus has gotten where it is today because it was generally an open standard, it's a non-licensed standard. I don't
Hmm.
think it's open source, but it's basically a lot of people could implement it. It's rather simple because it is created so long ago, and so it's just found wide adoption because of that. There are many industrial standards. Like you go to a trade show, like one of my favorite trade shows is IMTS in Chicago. Happens every other
Okay.
year, and it's just like 40-foot tall machining centers in the middle of a conference hall in Chicago. It is so cool. And you'll go talk to all the different vendors that are there, and they're like, "Oh, what kind of sensors do you need? Profibus, EtherCAT, whatever." Like, and it's just like there's just all of these different sensors and different standards rather. And but Modbus is open and or license free, I suppose, and just well proven.
Awesome. Awesome. Yeah, that's really interesting. I'm always interested in the like obviously familiar with a lot of the internet protocols and that sort of thing, but
Mhm.
now very familiar with I2C and SPI and that sort of thing. But then there's always something new. So
Right.
Modbus is one that I was happy to learn about through this reference design and your post also this week. They talked about it a little
Yeah.
bit.
It's interesting, even like I2C and a lot of the other ones that are out there. those were just the most successful of like big vendors. So like industrial is often big vendors saying we're just going to do it our own way, and then they publish it somehow, or it becomes this brand name, right?
Mhm.
I Squared C became, I think it was Philips who first did it, but it just became so ubiquitous it just kind of lost the plot, and so that's why you
Mm.
often see I Squared C referred to as two-wire interface, because I think I Squared C is actually a regulated term, but it's all the
I see.
same to us, right? It just got so successful that it got kind of genericized, like a Kleenex versus tissue sort of thing. Um,
Right.
and so in the industrial space, because it's so niche, and because these are such large dedicated companies, that like a lot of them just haven't hit that same scale, and I think Modbus has. So, but still in a very niche way.
Yeah. Awesome. Well, that's super cool. I imagine, like you said, that this reference design is going to be super useful for a whole set of customers who may have had to figure this out on their own without it.
Mhm.
Um, and I imagine also, I haven't looked at the reference design specifically, but this was perhaps not that difficult to do in the firmware because of Zephyr support as well.
So Zephyr does have a has a mod. I didn't write the code, so I won't speak about how difficult it was. But Zephyr does have a Modbus library, I believe, and then still hooking it. You have to still talk to the RS-485 transceivers. You need specialized hardware that's on the click headers shown in that post in that projects page,
Hmm.
and uh, you also uh, need to then process that data and then pass it to Golioth, right? So currently we have it so that we can talk down to the reference design. We can have it control the device, but then mostly it's a listener to the Modbus sensor readings coming back. One thing that we're doing in the future is the remote procedure calls to then genericize it so that it's not just talking to a banner sensor, but now it's talking to any sensor. You could basically just try out like, hey, relay location 4, trigger that, and then you could have kind of a arbitrary sensor plugged in.
Nice.
Yeah.
Cool. That is very exciting. Um, The other, I think, probably big announcement of the ones since you've been out is the Goliath usage visualization. So
Oh yeah.
in the console, being able to go in and see how you're using our various services. It's obviously a very short post, but have you experienced this at all yet in the console?
I did, yes, yes. I saw on the Thingy 91 project that I have in my account, I could see data coming through.
Nice, that's
Yeah.
awesome. Um, for
You
the
want me to show what that looks like or no?
Yeah, yeah, go ahead. I was trying to come up with a good transition there, but
Mm,
I won't force it.
got it.
And also, is that related to the demo that you were thinking about doing?
No, that's a little bit different. A little bit different.
Cool. Well,
So
we
I got
can
to
do them
go
both.
here. Can you switch to my screen? Should be
Yeah.
available still.
Yep.
All right. So I have many designs. I have multiple organizations as well. This is the Thingy 91 project. Um, and if I go to settings, now we can see usage. Oh, the month just changed. Let's go back a month. There we go.
Nice.
Yeah. So things are happening, and this guy's blinking away happily right now. So you can always see. I'm not sure if the beeps come through, but
Yeah.
yeah. So this is showing output streams and device logs and things like it. So that's great.
Nice. Very, very cool. Um, awesome. Well, let's jump into your demo.
Okay. One thing I wanted to show, and what I had been showing, is let's see if I can do this. I can show extra camera. What?
Can you present like multiple tabs or something if you wanted to?
I can do this. So I've
Oh,
got this little guy. So this is our follow along hardware. So, a lot of tabs open here. Uh, in the project, sorry, in our projects.goliath.io, we have many reference designs here. and this is the air quality monitor. And what people might notice with the reference designs that we often show them with this custom hardware, and that is often this kind of utility case kind of view here with a baseboard, it's got click headers, that sort of thing. And sorry, I should have done that bigger here. There we go. So this is the follow along hardware version, and then this is like what we often do. This is the older one here. This is a new version that I just got back from the fab, so we'll see a lot more of these white PCBs. There's red ones as well. And the follow along hardware basically allows us to instead of people needing this custom hardware, well, they might want to build on their own bench, and honestly, we hope they do. All of our firmware is open source, but then how do you then go and use it for your own purposes? And the answer to that is follow along hardware. That's kind of like the inverse of what we're seeing here, or my camera's reversed. I'm not sure. And oh no, it's just like this. There we go. Yes. So we do two things. One is we have a binary. So each of our reference design repositories generates a binary that you can then just go and download directly to the device. And that allows you to try Golioth without having any code compilation, right? So I showed code has gotten a lot easier using the VS Code code spaces that we do through our training. But even that is some amount of time and again, knowing where to click and whatever. So instead, you can go and just load it up using VS Code tools, right? So you can just NRF Connect for desktop tools. You can download the binary, load it, open the programmer, and load it directly onto your board. As long as you have the right hardware, which we show you how and what to buy. We tell you, buy these things, and then you're good to go. And then basically you have to go in and assemble it, install your SIM card, all that kind of stuff, put on this this interface. This is Arduino Uno headers with microbus interfaces there. If you have all that stuff, then you're kind of ready to go. And then you plug in the binary. Have the binary in here, and you're ready to go. You flash the firmware. But that only takes you so far, right? That takes you through the demoing it. You can see the data showing up on Golioth, and maybe you can even have let's see if this loads up. This is our Grafana interface here. It seems my board is not playing nice. We'll see if that connects. So my board isn't transmitting yet, but it looks here's an example piece of data, right? So when there's data sending through, it looks like this, right? We're charting data. We want to see just charts over time. So this is particulate matter stuff. This is CO2 concentration. We have temperature, humidity, and pressure. All these things. So this is basically what this hardware is doing on a regular basis. It's taking readings from the left side, passing it over to the NRF 9160 is a cellular modem. It's then passing it over cellular up to the cloud through Golioth, and then Golioth makes that data available on a REST API. Grafana is able to talk to the REST API, and we can showcase it here. So if you just use the binary like we talked about, you plug in all this hardware together, you download the binary, that should be about 5 minutes. Then you have your data on Golioth, you hook it up to Grafana, it's another 5 minutes, and within 10 minutes, you basically have a end-to-end demo of air quality monitoring, right? That's kind of what we think about there. So that's great. That's a demo. And you could show that to your boss. You could, show you could put it in your room if you wanted to monitor air quality. But then you want to take it a little bit further. And this is where close this stuff, close folder. So now you want to actually go and build it yourself on your local machine as well, right? So then we've started using the VS Code plugin from NRF Connect, right? So this is Nordic Semiconductor publishes this VS Code plugin. And if you wanted to go and build your own thing, you could do that, right? So what we're gonna do is we're gonna create a new application. And this is going to be kind of busy text-wise, I feel like. VS Code really layers stuff on top of one another.
Right.
But if you're used to the NRF Connect SDK way of doing things, which is the Nordic stuff, they then have this context menu that pops up here, and you could create a blank application. I don't recommend that for basically any connected project these days. I always start from someone else's code first. You can copy a sample. That's great. But now the application index, it allows you to pull in a bunch of this stuff that Goliath's already done and made it really
Mm.
easy to do. So what we're going to do is we're going to say browse application index. And wouldn't you know, there's our little Coral Goliath.
Hey,
And so we
hey.
have 3 things in here from Goliath, hopefully more soon. This is the reference design template, which is all of our stuff is based on it. The OBD2 asset tracker reference design. So that's using CAN interfaces. And then finally, the air quality monitor. So I'm going to click on that one. I'm going to say I want this. No, that's what I wanted. I'm going to do workspace AQM. All right. And what's happening now is basically on the background, in the background rather. And I can show you what it's actually doing because our friend showed me how to do this recently. So if I go to here, I go to output. So now we can see this is all the stuff that's happening that would be happening if you were doing this on the terminal yourself as well, right? So it's basically doing a West init, it's doing a West update, it's pulling in all the different sources that are in the West manifest, and then it's basically synchronizing and saying, okay, all that code is going to be now on in your project. Now, one thing to note about all this stuff is how we do things at Goliath, right? We want to have what we call standalone repositories. I forget what they call them at GitHub or at Nordic, but basically it's a completely self-contained project, right? So we want to make sure that when I'll say it from my perspective, when I come back to a project in 6 months, I don't want to pull the latest of anything. I want to lock all of my stuff in time, and I want to lock it against version numbers. And so right now we're on NCS, which is what we're going to just abbreviate NRF Connect for SDK. That's Nordic stuff that's built on top of Zephyr. That's currently at 2.5.0. Goliath is tested against NCS 2.5.0. So I have those 2 things in the West manifest file, and I say, no matter how many times I hit West update, I'm using 2.5.0 for Nordic, and I'm using, I forget what the Goliath version is for our stuff. I can look that up in a second. And then any other libraries I'm using, I call out all those versions. I'm not using tip of main. I'm not using experimental versions. I'm always using those. And that's really important for us from a maintainability perspective and just from a sanity perspective. One of the problems that I've run into in the past is where I point at a local version of like NCS that might be on my computer. I say it's a 2.2, but then another project that I'm working on, I go and like modify something in those files, and I've changed something now in what I expect to be this bedrock code, and it just makes it ruins my week, right? It just completely ruins my week, and so I think that's really, really important from a maintainability perspective. I think that's like one of the most substantial changes when I've started using Zephyr is just that, like, locking all the versions, because then when I decide to upgrade to 2.6 or whatever's new or new Goliath version, it's a very specific, it's a very conscious action, because I'm going to have to go into the West manifest file, change it, commit it, and then hit West update, and then get all the new stuff and see if there's any errors there.
Right.
Okay. So what I just did there is all that stuff just now. So the downside to this, and the only real downside, is that it downloads all of Zephyr and all of the NCS stuff in Zephyr as each time I do a new project. Now, I think that's a small price to pay. It's like, whatever the size of Zephyr is.
Right.
It'll load up your hard drive, but hard drives are cheap, and my time is expensive. So that's basically.
We had I don't know if you saw a few weeks ago, we had one of my friends on who didn't have any firmware experience, and we had a good healthy chat about that Wes downloads the entire world. But it does make it very easy when having that self-contained flow that you were talking about there. It does make it very easy to guarantee that it works the first time. So.
It does download the entire world. However, it does not commit it back up that's another important piece. So now I go and create a repository based off that. I don't commit that entire. So another thing we do is we break out all of the stuff. Oh boy, it's been a while since I've used Zephyr. We are within the app folder right now, but all of the dependencies are in a separate folder above it. And the important thing is we don't recommit it. I've actually seen projects before where someone went and downloaded all of Zephyr, this is not NCS specific, all of Zephyr, they went into one of the example projects, right? This is how I started doing it too, right? You go into Hello World, you start modifying Hello World, adding my own code, whatever. It's still within the example project folder. And then it's like, what do I commit? And then they committed the entire Zephyr repository to their GitHub. And it's
Yeah.
just like, but like that is so common. And that is one, a waste of time and a waste of space, but on the cloud. But also it's like, that's not really how it's supposed to be done. So we keep all of our application code in one place. We then pull all of the world, like you said, all of Zephyr or NCS into another space in a dependency folder. And then that's all locked. And that's what we're doing here.
Mhm.
So all of this to say, we now have all of the Golioth code that's in the air quality monitor is now here. And you can then go and start looking at how we talk to all the different sensors that are on this board, right? So this is a SPS 30 and SCD 41 and a BME 280, right? And these are all drivers that are in Zephyr that are there and ready to go, but you still have to implement them, pull that data out, have that data formatted, and then push it over to what we call app work. And in app work, this is where we have, we actually send data up to the cloud in the time series database, Golioth stream. So Golioth stream,
YDB stream
DB stream. I get
for
you.
now.
Yeah. Yes. So we just basically, so now I can go and build. So if I go back into the NRF Connect VS Code plugin, I can go and create a build configuration. I can go and select all the stuff I need to do to prj.conf. I want to have a fragment for NRF 9160 and DK. And now I have a build configuration and it's just like ready to, so whereas I said before, when we're on the code spaces and it was all decoupled from my hardware, this is now a localized version of the Golioth code. It's all pre-configured, it's all ready to go. And I can build it and load it to my device and debug it if I want to as well, and actually set breakpoints. So what do you think, Dan?
I think this is pretty neat. I did not know that. How long have we had the applications in the application index?
We had given some feedback about this, how we like to do standalone repositories and stuff like that. And that got us talking to the VS Code team, and they then asked if we wanted to put some things in there. So we've been there almost from the beginning. I think we were the second set of repositories in there. Our friend, so we saw Jared Wolf was in there, the Circuit Dojo stuff, Anamondo, that's a carrier that we know some of those folks too. So like it's a growing thing, but in terms of like the accessibility of like it just being in VS Code and ready to go, like that's pretty great.
Yeah, absolutely. I definitely think so. Especially if you were just getting started and you didn't even really know how to like use West necessarily or that sort of thing. Like this makes it very very easy. And I imagine also this plugin, does it also manage like if you wanted to just like tell it to build? Yeah, it looks like you have actions down there in the bottom left. So like it can really abstract quite a lot of this away from you.
Yes, and it does look like I did have an error here. So I likely did something wrong in my build setup, but nothing new there. Let's see. Oh, that's why I clicked the wrong thing. You know what I did? I think I used the roller on my mouse while it was over top. I bet I did that.
And
then
classic.
Yes. Yeah. So now it's gonna rebuild.
Nice.
Yeah, and this is so it's still not easy, right? Like Zephyr is a complex machine, right? It is a lot of stuff there, but we want to make it so that you can at least get to the point where, so first off, you can just load up a binary and you're good to go. And then you can build that exact same binary that you had, right? That, in my past lives, that could have been weeks of work. I know that sounds insane, but like, still same thing. Looks like we need to do a West update here. That's usually the TFM QC bore. I'll dig into that later. This usually
when it did it not do a recursive clone? Could that be it?
Let's see. And this is a good point of like when this stuff happens, it's tough with Zephyr. Like one of the other blog posts that we just published, the device tree shell, like when things go wrong with device tree, it is incredibly hard to like dig out what's the problem. And Chris, who wrote that post, Chris Duff, he's writing a tool that makes it easier to go and pinpoint those like so fast. Like that is a very, very powerful thing.
Hmm.
Does work best work here? Let's see. Let's update. Let's just try that. Looks like it's all right. So, boy, I did this today, earlier today. So I am not sure what I clicked wrong. It's not. See,
It's
use
just when you're
cached.
live
I
streaming, it
went
just
back.
happens.
Yeah, exactly right. Yeah,
Does it
you know
switch
what?
to the cached one after you
It
build?
does.
Yeah.
Yeah. All right, let's try this one more time. It's fine. I'm not going to actually load it up anyways. This is as far as the demo goes, Dan.
Cool. Cool. Now, we can chat a little bit about some of your hardware
Yes. Okay. Then let's.
where you really thrive.
Well, yeah. So this is the follow along hardware for the air quality module, but what you've seen in other ones is this guy, right? So this is that is a bad frame rate. This is basically what we call this is it's an ever changing process, but we call this the Aludel platform now. And this has taken a couple forms, like I showed before. This is kind of just like this is a bunch of dev boards, just where the green board is just gluing stuff together, a bunch of connectors together, and it's really gotten more complex. So in this one, this is the Rev A. The red is Rev A. This has the 9160 on it directly. It's still got the click headers. This is a battery cover here. It's got a buzzer. It's got quick headers. It's got high voltage inputs now, batteries, all that kind of stuff. And now we're on to Rev B for this hardware. And what we're hoping to open source, ooh, that is really bright. We're hoping to open source in the next few weeks this hardware, right? So this is it. Maybe I could share a screen a little bit easier. But NRF 9160, it's got an ESP32 backup modem. It's got a high voltage input, so it can go up to 60 volts. So like if you're doing industrial stuff like we talked about, often there's like a 24 volt rail. Well, that's great if you want to power your project, but a little 3.3 volt thing, you need to have some kind of interface there.
Right.
And so having a 60 volt maximum input supply, we can handle 24 volts, no problem. Right. And that's really, really useful there. What else is on there? We got some.
What were some of the changes from Rev A to Rev B?
Oh, so many. Dan, I made so many mistakes.
Well, tell us about some of them.
Oh, let's see. One, I didn't put a marking on one of the sensors, so that was backwards. I ordered the complete wrong part for two different components. That was just a sourcing issue. But another one, I changed the part last minute, so the pinout was wrong of the parts that I ended up using.
Oh, I see.
Yeah. This doesn't make me sound good as an engineer, but it's like hardware engineers will they'll feel this,
Right,
last minute scramble. Like that's when all the mistakes are made, is in the schematic when you're like trying to get something out the door to production. There's so many opportunities to mess stuff up there.
Right.
We have other capabilities though in this new one. Like we can turn off the power to like the whole kind of all the peripherals other than like 9160. We can turn off the power to all those, but now we can also turn off the SDA and SCL of the I2C bus, because those can also draw vampire current. So we need to cut those off too. So like just making better hardware all around.
Nice. When you were kind of like identifying these issues that you corrected in Rev B, what was your process like?
Leaning on the good. Oh, look at that. There we go. Turning on the brightness. Turning down. The goodwill of the coworkers. That definitely helps a lot. Trying stuff out and trying to break things and successfully breaking things. Yeah, and then just GitHub issues and tracking stuff. Well, I mean, that's hard to track changes, but I've leaned into using GitHub for a lot of hardware manufacturing and stuff like that.
But as far as like recognizing you had some of the wrong components, or you had a component backward, that was just like visually inspecting the board after something didn't work.
Yes. Well, that's testing and visual and checking and back to schematics and I don't like to rehash all these painful mistakes, Dan.
I mean, I couldn't have made this board, so the fact that you made a few minor mistakes, it puts you light years ahead where I am. So
I also
cool
did
to hear
not make
about
this
it.
board. This was made by one of our partners, Macrofab.
Mm,
And yeah, so there's a video we did right before the new year with Brendan from Macrofab as well. So if people want to check that out,
nice.
yeah, we'll
Cool.
call back. We'll call
Yeah.
back.
Gotta connect the content. So
Yeah,
um,
yeah, that's right. Let me see if
cool.
I can pull up this project. I can show it a little bit better. We also have the Astentis, which is the front panel. That's a new version as well, but is yet to be tested. This is an I2C based display that uses e-paper and has touchscreen and stuff like that. That is another thing we hope to open source this year. And it's got some firmware associated with it. It has a Raspberry Pi Pico because that's just a little beast of a processing machine, and then some reverse firing LEDs. People see that all over our projects page as well. Dan, I feel like I've been doing all the talking. While I pull this up, what else do you have? I mean, what else are you talking about? Any of your new stuff that I've seen little previews of, or no?
Uh, Probably not any of that stuff quite yet. Which
Mm.
I feel like we've been alluding to a lot on previous episodes as well. One of the reasons I'm not talking as much because I have less to talk about this week. So you're actually saving the day here.
Got it.
Um,
Got it.
but yeah, no, I think we're in kind of the as we get towards the end of our quarter here.
Mhm.
We have some pretty big deliverables. One coming next week. Which there was some engineering around, but it's more of a like a product change rather than a engineering change with just engineering stuff supporting it. So that will be announced next week, and we'll actually have
I know
Dylan.
what you're talking about. Yeah.
Yeah, I'm so glad.
Yeah, I'm clued
Uh,
in now.
yeah,
Big
we'll have.
changes. Big changes. You got to sell it more, Dan. Come on.
Well, we will have Dylan, who is our head of product here at Goliath, on next Friday, joining to detail that a little bit more. So,
Great.
keep an eye on your inboxes. We'll have more info about that. But otherwise, we have kind of like an ongoing larger project that we're hoping to deliver towards the end of March, and we're in kind of the I wouldn't say the home stretch of it necessarily, but more like we're doing like the critical things in terms of some of like the functionality that glues a lot of things together. So if you think about like the infrastructure that connects various components, a lot of testing. In fact, we actually made some improvements. Not myself. Our firmware team made some nice improvements to all of our hardware in the loop testing, which we've covered on here before, and made it basically such that we can run it against a bunch of different environments. So we have like a bunch of different infrastructure up and running that we can run our tests against, which allows us to ensure that when we swap new things into our production environment, that we've already tested it with real devices in the field, which is a huge benefit for sure. I think you're muted, perhaps. There we
That's
go.
great. That's what I was saying. That's great. That's great. You may have been able to read my lips, but
Yep.
I'm always saying that, you know? Um, yeah, so this is a close up on that hardware. I did waste a little bit of space just because I wanted to, make this quasi educational as well. So showing the different blocks and that sort of thing. It's not necessary at all from a to do this sort of thing, but we have fuel gauge, battery charging, all this stuff that you can read on here. So this whole area over here, all this stuff can get shut down using this 3.3 volt switch. So basically everything over here gets shut down. And that's nice from a power saving perspective, right? You want to shut down all your peripherals so they're not drawing any current when it's night time. Sorry, I have little kids. That's why I say night time.
Yeah. Cool.
Yeah. So we think this is going to be, so this is another target for, like I said, for these click headers. Obviously we have SIM card for being able to do that sort of thing. And then using the quick and or stemma headers here to talk up to that Astentis board.
The quick and the click is always throwing me
Yeah,
for
that is
loops.
unfortunate. Yeah. Quick is because SparkFun thought it would be cheeky to use I2C, so IIC. So it's QWIIC, which is very painful to look at when you're seeing it written down, but it
Yeah.
It works fine. I think
Well, we
you don't spell very often, but then I realized what it was.
right. Well, we work at a company where our name is misspelled, so
It's true.
we only have so
I don't
much
know. Maybe the
room to
Bible
go.
spelled it wrong, Dan. Do you ever think about
Maybe
that?
so. I mean, it's a
Yeah.
proper noun, right? So
Mhm.
it's not a
Words are
specific.
just things, man. Words are just things
Actually,
we
now that I
make up.
say that, I guess that Goliath is no longer just a proper noun. It is also just a word that is inspired by the proper noun. So
Right, right. And soon a verb too. Like I had an IoT project, but I Goliathed it.
I don't know if I like that.
I
We
don't
might
know
have to
either.
we might have to take that one by marketing before we, we throw it out
Yeah,
there.
that's fair. That's fair.
Yeah.
Yeah,
Cool.
so more on this hopefully in future streams. Basically makes it easier for me to plug together a bunch of reference designs. Um, that's that's what we're excited about. Being able to build these things. And so if people are interested in trying this for their own projects as well, you can start with follow along hardware. That's gonna be a lot faster. But then if you want to use this in your designs, use it as the basis for for future stuff.
Awesome. Well, that's super cool. Do we have another revision in the works already, or are most of the issues
Most
resolved?
things, yeah, most things are working so far. So
Cool.
yeah, gotta hopefully. I haven't gotten like deep into the hardware yet, but I'm feeling better about it. So
Cool. Awesome. Well, that's I think the total of what I had, or really what you had for today. But anything else you wanted to wrap up with?
no, hope people have a good week, and we'll work on renaming power saving to nighttime. Yep.
I'm a fan of that one.
Yeah,
So cool. Awesome. Well, Chris, I hope you have a good week as well. I
yeah.
think our weather here is going to be okay, maybe. That I usually can't say this because Mike is in Wisconsin. Oh no, actually
Oh yeah,
it's gonna be really bad. Sorry.
bad for Durham. Yeah, Dan and I are both in Durham, so
Right. Right. Bad for bad it's gonna be like 65 degrees, but it's gonna be rainy. So, you know,
oh, yeah, yuck, yuck.
you get what you get.
Yeah.
Cool. All right.
All right.
Well,
See y'all next time.
see you folks.